Hi, Assalamualaikum and good day. Today we are going to learn about limits of functions. These are the objective of today's lesson. By the end of this session, you should be able to state and apply the properties of limits and serve limits of definite functions. Following is the outline of today's lesson. We will start with the definition of limit, followed by properties of limit, and finally solving the limits of different types of functions as x approach to a real number and as x approach to plus minus infinity. Basically, limit of a function does not concern with what is going on to the function at point x equal to a, but it concerns with what is going on to the function around the point. In other words, limit is the behavior of a function near point of interest. Consider a function of fx equal to x squared. The graph of fx has a height of 4 when x equal to 2. Whenever the function is close to 2, the height is getting very close to 4. Thus, limit of fx as x approach to 2 is equal to 4 and written as follows. Next, take a look at the following graph. Notice that there is a break of height at point x equal to 2. If we travel towards x equal to 2 from the right, we will arrive at the height of 3. However, if we travel towards x equal to 2 from the left, we will arrive at the height of 2. Those heights do not match. Thus, limit of fx does not exist at point x equal to 2. Now, consider the following two graphs. The limit of gx and hx do exist at point x equal to 2. This is because there is no break at this point and both of the one-sided limit exist and have the same value. This means that if a graph does not break at a given x value, a limit exists even though the ultimate destination is a hole in a graph. Generally, a limit of a function fx exists at point x equal to a if and only if both of the one-sided limit exist at point x equal to a and have the same value. That is, limit of fx as x approach to a equal to L if and only if the limit of fx as x approach to a from the left and as x approach to a from the right is equal to L. Refer to example 11. You need to determine whether the following limit is exist. If exist, find the limit. To find the limit of the given function, you need to determine both of the one-sided limits, which refer to the limit from the left and limit from the right. Then, apply direct substitution. You will get the answer for the limit. For a, the function refers to a linear function, as the limit from the left is equal to the limit from the right, that is equal to 11, we can conclude that the limit of the given function as x approach to 2 is equal to 11. You may also find the limit using graph. Here I'm using desmos.com to plot the graph. From the graph, you will notice that the limit of fx as x approach to 2 is equal to 11. For b, the function refers to a rational function. You need to inspect with a graph. From the graph, for x approach to 5 from the left, the graph is moving downward. Thus, the limit of fx as x approach to 5 minus is equal to negative infinity. For x approach to 5 from the right, the graph is moving upward. Thus, the limit of fx as x approach to 5 plus is equal to infinity. As both limits do not have the same value, the limit of the function as x approach to 5 does not exist. Following are the basic properties of limits that you need to know. Example on each property is given on the right side. Following are some more properties on limits. Basically, the operation on limits such as scalar multiplication, addition, subtraction, multiplication, and division are similar to the operation on real numbers. Take note that for fx equal to 1 over x, the limit as x approach to 0 from the left is moving downward, which is equal to negative infinity. The limit as x approach to 0 from the right is moving upward, which is equal to positive infinity. The horizontal asymptote of fx is at point y equal to 0 and the vertical asymptote is at point x equal to 0. Asymptote refers to a straight line that a graph approaches without touching it. Refer to example 10. You need to find the limits for the following functions. A, B, C, and D involve the basic operation addition, subtraction, multiplication, and division. By applying direct substitution and simplify as usual, you will obtain the following answer. E and F refer to power and radical. By applying direct substitution and simplify, you will obtain the following answer. In the following section, we are going to discuss on how to compute the limit of the following function for x approach to a real number. Limit of function as x approach to plus minus infinity will be discussed in the next lesson. Let's start with the polynomial function. To compute the limit of this type of function, you may apply direct substitution. Refer to example 11. By substituting all the x with negative 2 and simplify, you will obtain 116 as the answer. Next, proceed with the rational function. To compute the limit of this type of function, you need to find the limit of both numerator and denominator separately using direct substitution. Divide the two answers, you should be able to get the limit of the given function. For A, by applying direct substitution, you will get 6 and 4 as the answer of limit of numerator and denominator respectively. Divide the two answers and simplify, you will get 3 over 2 as the final answer. For B, by applying direct substitution, you will get 0 over 0, which is not equal to 0. For such case, you need to simplify the function using factorization before you can apply direct substitution. By factorizing both numerator and denominator, you will notice that they have a common factor, which is x minus 3. Cancel this factor and simplify the function, you will get 3 over x plus 2. By substituting x with 3 and simplify, you will get 3 over 5 as the final answer. For C, you also need to simplify the function using the factorization. By factorizing both numerator and denominator, the common factor x plus 3 can be cancelled. Then, substitute x with negative 3 and simplify, you will get 0 as the final answer. For D, you need to simplify the function using the rationalization, meaning you need to multiply both numerator and denominator by the conjugate of the surd, that is, square root x plus 1. Simplify the function, then substitute x with 1, you will get 1 over 2 as the final answer. For E, you also need to simplify the function using the rationalization by multiplying both numerator and denominator by the conjugate of the surd, that is 3 plus square root of x plus 7. Simplify the function and then substitute x with 2, you will get -6 as the final answer. To compute the limit of trigonometric function, you need to bring the appropriate constant outside the limit and apply the suitable properties. For a, by moving 1/5 outside the limit, the function can be simplified to sin x over x. By applying the first property, replace the limit with 1 and simplify, you will get 1/5 as the answer. Next, for b, you need to divide both numerator and denominator by 2x so that the first property can be applied. As limit of sin 2x over 2x equal to 1, simplify, you will get 3/2 as the final answer. For c, divide the numerator with 5x over 5x and denominator with 3x over 3x and simplify. Then, apply the first property and simplify again, you will get 5/3 as the answer. Next, for d, replace tangent x with sin x over cos x. Then, split the function into two, first with sin x over x and second with 1 over cos x. By using the first property and replace x with 0, then simplify, you will get 1 as the answer. For e, split the limit into two. For the first limit, the answer is equal to 1. For the second limit, 1 over cosec 2x is equal to sin 2x. Replace x with 0 and simplify, you will get 1 as the final answer. Finally, for f, multiply both numerator and denominator with the conjugate, then simplify, apply the first property and replace x with 0, you will get 0 as the final answer. Proceed with the last example, which is on the piecewise function. For a, to find the limit of fx, first you need to identify the function to be used. As x equal to 0 is greater than -2 but less than 3, the function is referred to x squared minus 5. As the limit from the left is equal to the limit from the right, that is equal to -5, we can conclude that the limit of the given function as x approach to 0 is equal to -5. For b, as x equal to -8 is less than -2, the function to be used here is 3 over x plus 2. As the limit from the left is equal to the limit from the right, which is equal to -1 over 2, we can conclude that the limit of the given function as x approach to -8 is equal to -1 over 2. For c, there are two functions to be used. For limit from the left, the function is 3 over x plus 2. And for the limit from the right, the function is x squared minus 5. As the limit for both sides are not equal, the limit of fx as x approach to -2 does not exist. Finally, for d, there are also two functions to be used here. For limit from the left, the function is x squared minus 5, and for the limit from the right, the function is square root of x plus 13. As the limit for both sides are equal to 4, the limit of fx as x approach to 3 is equal to 4. In order to check your understanding on today's lesson, please do exercise 1.2. In the next lesson, we are going to continue our discussion on limit, that is for x approach to plus minus infinity. So, stay